Welcome back everybody to another video lecture from Miss Semino. This video is actually from your chemistry honors textbook, but I thought it would be a good introduction to kinetics. So our first objective in this lesson is to describe the general relationship between the value of the specific rate constant K and the speed of a chemical reaction. We need to interpret the hills and valleys in a reaction progress curve. So when looking at chemical reactions, we like to write rate laws for them. They can help determine the speed of the reaction. So here it says for the equation A, your reactants turning into B products, the rate at which A forms B can be expressed as the change in A, or delta A, with time, where the beginning concentration A1 and the beginning time is T1, and the concentration final is A2, and the final time is T2. So you can see that rate is the change in A's concentration over the time that happens. The equation truly looks like this. There's this negative sign out front, and that's because your concentration or your amount of A is decreasing over time. And then here is your change in time here, and it's proportional to the concentration. Since the rate of the reaction is proportional to the concentration, we can say the exact proportionality by using this constant here, K. So it says here this equation is called the rate law, and it's an expression of the rate of a reaction in terms of the concentration of the reactants. Again, notice this little negative sign out front. And again, we need that negative sign because our rate needs to be a positive value, and again, this delta A is probably going to end up to be a negative value. So here we have another K. I kind of wish chemists would have found another letter. If you guys remember, we had the uppercase K for equilibrium constants, but notice now we've got a lowercase k. So the specific rate constant, lowercase k, for a reaction is a proportionality constant relating the concentration of the reactants to the rate of their reaction. So if your K value is large, you're going to form your products quickly, and if your lowercase k is small, you're going to form your products slowly. The order of a reaction is the power to which the concentration of a reactant must be raised to give the experimentally observed relationship between the concentration and the rate. So it's kind of this is how we write our rate law. Here's that proportionality constant, that lowercase k. Here's our concentration of A raised to its coefficients. You guys can see these coefficients here. We're raising the power here. This is kind of like writing our equilibrium expressions, except for we're just using the reactants. Then if you did have another reactant, reactant B in this case, you'd raise it to its coefficient as well. Again, notice that we're not using the products here. So we've talked about rates of reaction before and factors that can affect them, but when we're specifically looking at a rate law, there's three things that can affect this rate law. The concentration, or the molarity, also known as the molarity of each of the reactants, the power to which these reactants is raised, and remember we're getting this power from the coefficients, and the value of K, or the rate constant, which is different for every equation, chemical equation. Okay, now when we look at a rate law, one of the questions that will sometimes be asked is what is the order of the reaction? So the powers to which the concentration are raised are calculated from experimental data. In AP Chemistry, you'll hear this mentioned 18,000 times in the lectures that we do. So these exponents are found from experimental data, and these powers are called orders. For example, if the exponent of A was 2, we would say the reaction is second order in A. If the exponent of B was 3, we would say that there is a third order for B. The overall reaction is the sum of these orders. So if we were to take the 2 from A and the 3 from B, the overall reaction of it is a 5-order reaction. So reactions can happen in single steps, or they can happen in multiple steps. If a reaction is happening in a single step, we'll call this an elementary reaction. And when we look at an elementary reaction, we only have one activation energy peak between the reactants and the products. Something to pay attention to is that the peaks are energies of activated complexes, and the values are the intermediates that form. So I don't know if I'm able to draw this picture here, but if we're coming up here, okay, we would have our activated complex would be at the top here, and we might have an intermediate like down here somewhere, and then we would have our final products. So when we use the term intermediate, it is a product of one of the steps of the reaction mechanism. And so we can kind of add these equations up and to figure out what the overall chemical equation is going to be. And so we actually have seen intermediates when we were doing Hess's law. There were things that were being canceled out. So here it says, remember how Hess's law of summation was the total of the individual reactions added together to give one equation. And so we can do that when we're talking about reaction mechanisms as well. So here's just a little diagram. We can go ahead and look at the questions. I know the answers are right there, but let's go ahead and explain them. So this first one says, how many elementary reactions are part of this reaction? We're saying that there's 4 because there's 4 peaks. Read how many intermediates are formed. And intermediates here, here, and here. So we're going to say 3 intermediates are formed because those are at the valleys. How would the catalyst affect the energy of the reactants and the energy of the products in this reaction? Well, it says here a catalyst would have no effect on the energy, just the rate. So if you remember the definition of a chemical reaction, it doesn't affect the equilibrium, but it does affect the overall rate at which the reaction occurs. So in class, you guys, we're going to be talking a lot more specifically about how to write rate laws, and we'll have practice doing that, and we'll be entering the values of those concentrations in there to find K. But I hope that this video was helpful as an introduction. As always, remember to write down any questions that you have. Thanks.